And now I will officially start the webinar. This is Steve Case with Electro, and welcome to our Fast and Furious webinar series. And today we're going to talk about 400 gigabit testing for today's transport networks. And our guest and speaker is John Anyas from Anritsu. And John has been in the industry for many years, and I think new to Anritsu, John? How long have you been with Anritsu? Good morning, too.
Oh, hey, good morning. Let's say I'm in my 8th year.
Oh, okay. So you've
So
been,
I'm in here 7 years.
there you
So
go.
I still feel like I'm the new guy here, but
There you go. All right. So John has lots of experience, and we're going to, which probably you need to get that to talk about this subject today for 400 gigabit testing. But before we move on, I'm going to just have a small commercial here for Electro. We're a large test equipment provider for rental and for sales. In some instances, we have about a $1.2 billion worth of inventory, actually all over the world, a lot in the US and California, in the UK, in Europe, India, Asia, and wherever you need equipment, we can provide it. So that's one good thing we have. And actually, another good thing we should have, since we're here with Anritsu, is we have a lot of Anritsu equipment across the country. We actually have a lot of Anritsu equipment in Europe and in the US, and we can get it just to about wherever you need it. And before we jump into the presentation here, I just want to mention that I will be looking at the Q&A section of the webinar. So if you do have a question, please ask. We'll be stopping here during the webinar and seeing if there's any questions. So that's what we'll be doing. And with that, John, I think I'm going to flip it over to you.
all right.
And here we go.
Okay, show my screen. Great. Again, hello, my name is John Anyans, and I'm an FAE with Anritsu. I support transport products, OTDRs, things like that. Today we're going to talk about 100 and 400 gig transport validations in a network. This synopsis. Okay, so kind of the overview of what we're going to talk about today. We're going to discuss 100 and 400 gig commissioning validation process. On a transport system, and some of the things you might encounter when you are asked to validate such a connection. Real quick, I've got a quick kind of diagram, a drawing. This would possibly be a typical transport network. In this case, 400 gig. We're going to mainly stay with 400 gig, but the ideas for 400 and 100 gig are really similar. But 400 gigs, kind of the emerging line rate these days. So we'll have a transport tester on one client port. It's going to traverse a transport network. You could see here 400 gig client, then it goes into like a DWDM transport and comes out on at some point on maybe on a ring or however they have it architected, come out on another client, and we'll basically either provision a loopback or put a hard fiber loopback in the far end client port, and that'll basically complete our connection. I'm going to mainly talk about Ethernet BERT. To me, it's kind of like it's a workhorse application. We'll talk about RFC 2544 and WIDAT 1564, but to me, the more useful and the quicker applications, Ethernet BERT. I'll also talk a little bit about forward error correction, especially because 400 gig runs with forward error correction or FEC on all the time. We'll go through kind of at least my view of what this process is. So if you're a contractor and you're you're asked to come in and validate some connection like this for a network equipment manufacturer. I'll give you a view of a couple of experiences I've had, and actually I've been in the kind of the transport business for a long time before I started at Anritsu. So this is nothing new to me, but it may be something new to you. And I'll just kind of tell you what my views are and how to validate these things. So you see here, I just kind of stretched that loop out. All I'm really trying to show you here is that same transport network, as big and scary as it is and it looks, for all intents and purposes, it's a big loop. It could be a fiber loop at the end of our transceiver, and you'll see that actually comes in handy when we're isolating our test solution from the transport network that we're validating. So where do we start? Where we get this job and we need some information. The first thing I'm going to ask is what is the line rate? And we're within the scope of this discussion. We're either talking 100 or 400 gigs. So we got to find out what that is. That's pretty straightforward. The next thing we're going to need to know eventually is what is the optical power required for the transceivers we're working with. Maybe we've got a far-reaching 400 gig transceiver, and we only really need to go a couple of meters through a patch cord. We need to know these things. These transceivers, you can find data sheets on them online, and you can understand what the receiver power is that's required for these parts. The next thing we're going to have to know, though, is we just can't hook this thing up and run it and say, hey, it runs at this error rate or whatever. We don't know what a pass or a fail is. We need to have that defined. We need to know why are we testing this? What denotes a good connection versus one that's not acceptable to the customer that asks us to do the work. So the pass-fail criteria needs to be defined. There should be a test plan or some document that defines this, and if it's not defined, we need to ask the customer that asks us to do the work. We need to have this information to do the job correctly. And then the last two, I'll kind of put these together because they're similar. Where are the endpoints of the connection? This is important. If we can get away with a loopback, which most transport connections, you're going to be able to get by with a loopback, but it might be routed data. You might have a near and a far end connection that need actually two transport testers, one on each end, and because it's routed traffic, and you need to either have a reflector on the far end, or you're doing kind of an end-to-end Ethernet transport test. So that's important to know is where they're at. You may be going end to end, but the patch panel that has both connections is nearby. So maybe you could use a dual port solution. So it's important to know what those are. And then the last one, I've already kind of let the cat out of the bag on that, is will a loopback be allowed on the far end? In my experience in transport systems that aren't doing any kind of routing, it's gonna work fine with a loopback. That's perfectly acceptable. So once we're provided the test plan, there's a lot of information in there that probably isn't interesting to us. We're really looking for that pass-fail criteria. If the customer doesn't come right out and tell you, I want to run an Ethernet BERT and I want it to be error-free for 15 minutes, we have to go in this document and look for it to understand what this pass-fail threshold is. Also, we need to know what the duration of the test is going to be. All connections are going to take an error or take errors in their life. The longer we run the test, the more likely we are to run into errors. If our work's being judged on an error-free connection and the requirement's only 15 minutes, but we leave it hooked up and maybe we let it run overnight, or we go out to lunch and come back to check it, we've now increased our risk of taking errors. It's important to stay within the constraints of the test plan. Set the duration for the time, or if your test solution doesn't allow that, then you have to stand there and look at it, look at your watch or look at the duration of the test and stop it manually. The box I'm going to show you a little bit later has the ability to set that duration, by the way, and I strongly encourage it. If they say 15 minutes, run it 15 minutes, give them their report. If they want 2 hours, you give them 2 hours. Sometimes they'll want a 24-hour test. But knowing what that is important. I have actually a little snippet from what I would call a test plan or a test document or some type of documentation. There's tons of information in here. But the only thing I could find in it that talked about this connection validation was BERT testing. It didn't even have a duration, so we had to ask for that. The technician that I was working with asked me, how long do I set it? And I said, well, some examples I've seen recently were 15 minutes. When he proposed that, the person in charge said, no, let's make it 2 hours. Fair enough. Seems like a good test. At the end of the day, we're not looking to test the design here. We're really just looking to make sure that the work was done correctly and it was installed correctly. So we're not looking for worst case testing. We're just looking to make sure that the work was performed as the customer wanted. So now we've got everything defined. We need to find a tool now to measure our connection. So this is where something like an MT1048 could come in very handy to measure this 400 gig connection in an Ethernet BERT application. What I've seen mostly is that the vendor will describe what test solution is needed for validation of the connection that you've installed. If they haven't, then it's your prerogative. You can shop around and find a test solution that's going to meet your needs. And like we mentioned earlier, Electro Rent has these on the shelf. So if you needed to rent it, you don't want to own it, it's definitely a great solution. Get the box. You get a guy like me to walk you through it and understand how to use it. And it's really pretty easy to use, to be honest with you. Don't tell my boss. So what's the process? We've defined our connection with a pass-fail threshold. We know our line rates. We've answered all the questions we need. We have a test solution now. What do we do next? In my opinion, to keep things clear, we need to reduce the variables because we're testing something that's unknown. It's very possible that the test solution itself is unknown to us as well. So the more that we can define and isolate and validate before we actually test the connection, the better off we are. And so in this case and in this scenario, I recommend that you do a fiber loopback on your transceiver in your transport tester and run your Ethernet BERT and make sure that's error-free. You don't have anything misprovisioned in your measuring device. So what I've got depicted here is that initial loop we had at the far end. That's equivalent to this loop here that you would put on your transceiver. I actually took a picture of a small loop I carry around with me that I can loop back into a transceiver. You might have, a single LC fiber that goes, so many meters, and you could loop that around, and that's fine. But the idea is test this loop, run your Ethernet BERT solution, make sure it's error-free before you actually connect it to the connection under test in your transport system. So now we're going to get back to one of those questions we had to answer, our optical power. Hopefully your test solution has an integrated way to measure your TX and RX optical power like the MT1040A does. Pretty easily, I could come in and look. I actually could look at a lot of transceiver information. But one of the nice things, and this isn't a 400 gig device. I'll show you an example of that in a minute. This is a 10 gig device, but the idea is the same. The TX and RX power, there are registers in the transceiver that the box can interrogate and find what the TX and RX power are. And if it's too hot and if it's outside of the range of the specification for your transceivers, you get something like an inline attenuator and knock that optical power down to meet the requirements of the optical power. You don't want to overdrive your receiver, and you don't want to underdrive it, because in each case that could be adding errors or an outright packet loss or frame loss that's not measurable if your power is out of the range. Typical rule of thumb that I found is that you want to be right around 0 dBm at your receiver of your transceiver, and that would be for the receiver on the test unit itself, as well as the client port that you're connecting to in your transport system. So that's the other transceiver we need to understand what that RX power need is. But typically you can get away with 0 dBm is an acceptable level. Some maybe need it a little lower. Rarely do you want to get hotter though. So let's talk about some of the test applications. And I'm going to show you examples from the Anritsu MT1040A Network Master because that's what I have, and it's a box that I like. So like I was talking about earlier, the workhorse, the application that I'll go to 99 times out of 100, if it's me just doing the work, it's going to be Ethernet BERT. The reason that I like Ethernet BERT is it's relatively quick. If you want to compare it to a couple other standard tests like RFC 2544 or WIDOT 1564, Ethernet BERT, you get a very a much faster feedback as to whether you're in the ballpark or not. So if you have problems, some of the other tests take a little longer to roll and get a result from. And if you're making changes and then running a test and making changes and running a test iteratively, if you have a long leg in that testing, it's going to slow you down. The Ethernet BERT is going to be your fastest feedback, so it's going to get you through whatever issues you might be working through quicker. Then you could actually move to an RFC 2544 or WIDOT 1564. Unless you're very confident in your usage and your setup. I always recommend to my customers, especially when they're first getting used to this test platform, is to do your Ethernet BERT, get your stream correct, and then look for your key performance indicators, like your bit error rate, your frame errors, forward error correction margin, latency and jitter might be some thresholds. So far, I've only really seen an ask for bit error rate measurement though on the connection. RFC 2544, just briefly, got a couple examples of some screenshots of this test application. It's a standard test. It's been around for a while. The idea here is that you're looking for the maximum throughput through your connection, or sometimes I'll call them pipes. But you're wanting to understand what the maximum throughput is. I have seen some applications like Ethernet over Sonnet where they don't have all of the members of a link aggregation group fully provisioned. So it's something less than the maximum line rate. RFC 2544 characterizes that very well. If it's something less, if you're expecting to have maximum throughput, RFC 2544 can be a lengthy test. It'll test 100% all the way down to 10%, or however you decide to provision it. So that's what that test is for. It runs a single stream. So does Ethernet Burp, by the way. It runs a single stream. There is another application I don't have in here called Monitor Generate that you can do multiple streams. This next test that I'm going to show you is a multiple stream test, and its purpose is to validate a service level agreement, or an SLA. You may have heard of this. It has the service acceptance criteria, or SAC, thresholds, like committed information rate and frame loss and frame transfer delay, which is kind of a latency measurement, and frame delay variation, which is kind of a jitter measurement. But these are defined in this WIDAT 1564 test. This is a test that is known through the industry as well as RFC 2544, and it's a newer type of a test, and like I said, multiple streams. One thing I did kind of want to segue into is that maybe you are asked to test not just one connection on one day of the week, but maybe you have hundreds of connections you need to go through. And maybe your test plan is a little more elaborate than just running an Ethernet burp. You could stand to automate your test, and the MT1040 offers a very robust, it can be very simple or sophisticated automation, and very powerful, where it can add instructional pictures and dialog boxes, and tell you to wait and do the instruction A before you proceed, kind of a deal. You can batch up test. So let's say you wanted to run an Ethernet BERT, then follow it with an RFC 2544, and then follow all the WIDAT 1564. You could put them all together and just click on one icon to start the whole thing, and then you hit your run button and it goes through, and it tells you what's going on. So very, very powerful onboard within the scope of the network master. This application could be powerful. Now, you don't want to go for this, right out of the gate, because it does take some development time. This is only something that if you have some repetitive tasks and you want them to be accurate and run for the same durations, and you want every member on your team to do it the same way, or you need that instructional process kind of a look. This is a great way to ensure that. It's by using this automation tool. So then, just to talk about a recent example, I've kind of been alluding to some of them in here, but this recent example, I was contacted because I support Electro rent when they rent our equipment. So I'm the guy that would support this equipment. I was contacted to support a customer that had this unit in the field, and it was the first time. So I got on the phone and we were talking. They had a Network Master Pro 400 gig. They were verifying a 400 gig connection. We talked about the connection type that they had to validate, and it's basically everything I've described to you. It was a transport system, DWDM. By the way, I used to work on these systems for another company for many years. eventually ending up on a DWDM system. I actually remember when T1 was a new technology, so I've been doing this for a while. But we had a big DWDM transport system, and so I was very comfortable with working on this this with them. So what we did was just basically everything I described. We did have some downtime before we were actually able to connect to the transport system. So we took that time to verify the setup and have a setup. We saved a favorite, which you can do on this unit. So all he would have to do is click on that connection and or click on that favorite, which was all of his provisioning for the test setup that we provisioned for him. So when he went back the next day, all he had to do was click on that and run his test. We looked at the optical power. We did have to make some adjustments. Yeah, so the inline attenuators will come in handy there. There's other ways to get around that, but I probably don't want to instruct you to do that. I think the inline attenuator is the best way to go there. So over the phone works fine, but my support for you is much better if we get a VNC connection and you give me keyboard and mouse control and you share your screen with a VNC viewer session. The unit comes with VNC server. It's a very, very good way for me to get in and see what you're doing and see what's happening, and I can make changes to debug what's happening a lot quicker. It's as if I'm sitting there with you, but you might be a half a country away. Very powerful way to support you though, and very quick. In this case, we did have to set a duration, and it was once we had it all together, it was actually pretty easy. Customer was happy. So what I'm going to do here now is actually I'm going to go off road a little bit. I'm going to go to this link. This is the landing page for the MT1048, just to give you a quick tour. Checking on the time. How are we doing for time? Do I have time to go through this?
Certainly, yeah, absolutely.
Okay, great. All right. Sometimes I could talk your ear off, so you got to stop me. So
No, 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 it's all good.
let me hit escape here, and I'm going to get over to a browser. And just drag that over. And I'm not going to beat this guy to death, but just to show you, I just Google MT1040A Anritsu, and this is like one of the guys that shows up. Look for the Anritsu.com link. Otherwise, you might get an ad. You probably would see Electro ad for this as well. But if you want to get to the manuals, look for the Anritsu one. And this is like a one-stop shop. If you probably have to worry about upgrading, although I will upgrade a unit if I find it's not the latest and greatest. If I have the opportunity in the field, I'll ask the technician or the customer, whoever has the box, I'll ask to upgrade it, especially if there's some questionable behaviors. I want to make sure I'm on the latest load. All your downloads are on this button. If you want to come to this site, there's some videos here. There may be some topics that are interesting to you. I highly recommend seeing them. They're usually not very long, so they're not going to take up your whole day. But if you're interested in looking at something, these videos are nice. I actually make videos myself that I'll share with people for specific things like how to do VNC, for instance. If you want to connect your network master up with VNC and use it to remote control, and you get support from me. The other one I just want to just click over to real quick is this library tab, brochure, product introduction, but most importantly, operation manuals are all here. Come in and you click on one of these, and if you have your browser set up right, it'll open up the manual. You can look for different pieces of information. So everything you need is here. And then I think the last thing I want to do, I'll share this presentation again, get back on road, and we'll just do a quick BERT demo again. I'm asking if we have time. I have a VNC session connected to my my laptop. Escape again here. Let me just throw this up here. This is a VNC viewer. This viewer I've had it on this laptop forever. Real VNC, but there are other VNC viewers. What you're seeing here is the MT1040A. It's sitting right on the bench behind me. I'm remotely connected to it through my home network. It's very easy to connect to. This is the application screen. This is what you'll see when you open the unit up or you start the unit up. This is a touch screen, and everything that I'm showing you can be done with the touch screen. So it's one for one. I've already got the Ethernet BERT application open. Just to show you, there's kind of some call them the warm fuzzies. You want to make sure that your link comes up. The 400 gig parts come up a little slower than maybe what you're used to at 100 gig and below. Take a while for the link to come up. So don't panic if you don't see it right away, but eventually this has to be green before you proceed. And then you'll notice there's some other things. The link speed gets negotiated. You want to see 400 gig and you want to see full duplex. These little buttons can give you a little more information if you need a little more detail. The next thing you're going to want to do is start your Ethernet traffic. You notice our port status went red when I turned the Ethernet traffic off. Now this is just the traffic. We're not making a measurement. We see our port status went solid red, and then it went green with a red ring around it indicating there's a history of trouble. Maybe we made an adjustment to a fiber or something. We can clear that and let that settle. We want to make sure everything's good. Again, there's more information here that we could look at. Now, we were talking about the light levels. I can interrogate the transceiver on this transceiver button here. And I could see the aggregate power. Now I'm running a little hot. This device I have is an MPO device, so I don't have an attenuator for it. It's over 0 dBm. It's a little more. And I could actually see each of the 4 lanes. This part is running four lanes of optical signal, so I could see what their individual powers are, and we can look at other things like vendor information, for instance. So there's a lot of information here if you needed to get at it. And then very quickly move over to our stream information. I have source and destination MAC. I'm running Ethernet IPv4. We could pick a different kind of a stack, we'll call it, like VLAN Q and Q, IPv4 if we wanted. So we have varieties to run. In this kind of testing that I described today, this is fine. You can run anything you want. That's actually the beauty part of all of that. You could run this stuff. Now, you may need to run something specific to that connection. Ethernet IPv4 is very common, so that's kind of my go-to. Set your source and destination IP addresses, and if we needed to run some test constraints, like we talked about duration, we have the ability in this unit, instead of a manual start and stop action, I could start it at a specific time, but we talked about duration, and that's actually kind of important. This kind of testing, we'd want to set a duration, then we could set a time that we want our test to run. But in this guy, I'm just going to say manual stop, and I will start. Let's see, we could real quick. We'll touch on the profile tab. If we want to change the frame sizes or anything in this Ethernet stream, we can do that. We even have some profiles. I'm running 100% line load, but we have these ramping profiles. So if you want to ramp up and control the line load for whatever reason, you have that ability here as well. So I'll just start the test. We're actually making a measurement. The unit will immediately bring you to the results screen, and we're on a summary tab. We see our utilization is 100%, which is what we expect. We see 0 errors, and being that I'm more or less in a lab environment, I expect to have 0 errors. If there was trouble in like an overnight test, I have an event log to look for events that are timestamped that I might correlate with performance monitoring on my transport system, to kind of paint a picture of what happened during the long-term test. Statistics, I can come in and look at those details. I do have it set up to look at latency. I am in a loopback, so these are very, very small measurements. And then the last one, kind of a powerful feature here, is forward error correction analysis, or this forward error correction distribution. Not to beat the forward error correction horse to death, but you could see that natively this part's running at an e to the -7th symbol error rate. So there is some symbol errors that are being corrected, and this histogram tells me how often and how deep they're being corrected. So there are some code words that are being corrected up to 2 symbol errors. I would rate this or characterize it to be a very robust margin. If I was running out here to 13, 14 symbol errors every so often, that doesn't leave a lot of margin for any environmental, anything that's outside that might affect my my performance, like a macro bend or something that's introduced, or a change in temperature that may affect fiber, or some type of strain like weather. Those errors are going to be eaten up by forward error correction. But if you're running over here, once you get to the end of your forward error corrections abilities, you're running like 15 symbol errors, you don't just start, this will run error free just like this will. But if you're running in this region and you encounter some impairments, your connection error rate is not just going to start degrading off, and where you start to see an error rate like this. It's going to be 0 or it's going to drop. And that's the kind of the dangerous part about forward error correction. It can lead you into a false sense of security. So it's good to know what this margin is. I hope I didn't scare you, but I hope I did describe to you the importance of understanding this information about your connection. It's probably not enough to know just what the error rate is. It's probably just, or even more important, to know what this forward error correction margin is.
Hey, John, I have a question.
Yes, sir.
So when you're at 400 gig, FEC is always on. It's not.
Yes, it's on all the time. So at 100 gig is optional. At
Okay.
400 gig, there's no option. Or as you see here, we'd be running at an error rate all the time, and that wouldn't be acceptable. So they actually need forward error correction to make this part run error free. So it's not negotiable. It's on all the time.
Right.
And
Okay.
you need to know what that margin is. Now, you don't necessarily need to know it. Maybe the customer might want to know it. You could offer it to them. But I think eventually, as people get more experience with these parts, and you're going to hear about some stories maybe where people were dropping traffic on something that was commissioned to run error free. This, I think, is going to become a test that's run more and more. It's going to be part of like a closeout package or something. As we move forward, 400 gig still relatively new. So I think this is going to be an important thing. And speaking of the closeout package, when we stop our test, and forgive me, I didn't have anything kind of pre-planned here. This was for a customer, just I was showing them an example of something, but you could come in here and generate a report. Just very quickly, I'll just make a PDF report just to show you. we'll call this this ER, and we'll hit OK. So we have a name for our report. We'll save the report. It'll generate the report, and there's a utility on here to view the report. So rather than save the report to a PDF and then go look at it on our laptop, we could actually look at it on the Network Master. And I think the powerful part of this is that you can just review your report to make sure everything is as you wanted it before you maybe move on to the next connection or leave the customer premise to come home and find out that the report had some kind of errors in it that you didn't know about maybe, or you didn't notice, and you could see them in the report, and go back and rerun the test, or make it say, hey, we have some kind of issue. Let's take a look at that. Let's maybe correct that before we leave the site. So it's helpful. I think the other neat thing about this is you can actually throw an icon. So I could like put the Electro run icon up here in the upper left. I don't have an example of that right now, unfortunately, but it's pretty easy to do. You just snip off that logo, save a PNG, and then tell the report, utility where to find that. So I usually have a folder on my Network Master that has these icons. And I hopefully didn't talk your ears off. That's all I had to share. If you wanted to go to a Q&A.
Yeah, this would be a great time for people to ask questions. I had my question answered, but actually I did just have, out of curiosity, since I'm not in the business here, so to speak. We're talking primarily 400 gig Ethernet protocol, but there are other protocols, OTN
Absolutely.
and SONET
Yes.
and things, and those are also supported, right? Are,
Yes.
are they not as are they still dominant, or is Ethernet just taking over, or what?
So this is my opinion in what. So remember, I'm just a worker bee making sense of the shadows I see on the cave wall, right? But yeah, I do see transport technologies like SONET and OTN giving way to Ethernet. Fiber channel, I actually don't have a lot of experience. I hear they're used a lot in data centers, but Ethernet seems to be the dominant transport technology that I'm seeing these days. Most of my interactions with customers are about Ethernet. My
Is it
my
because it's just
upbringing,
easier to deploy for
um,
people?
yes, it's no muss, no fuss. Sonnet, that was where I had most of my experience, and even before Sonnet, T1 and T3. Um, we thought that would never go away. It was synchronous, as synchronicity was needed, and networks, they have ways to do uh, uh, transmit timing over Ethernet now with this um, precision timing protocol, or PTP. We do have a solution, by the way.
IEEE
Yeah,
1588.
and
Yeah,
it's an older technology, but it's being used a lot in like 5G deployments, where they need very tight timing distribution for things like their lambda transmission in off the tower is over a single lambda now a lot of times, and that timing needs to be very tight. So PTP is often used in that regard, either as a primary timing or a backup timing to GPS. And that PTP is derived from like a GNSS or a GPS antenna. It's very, very accurate. So we do have a solution in the MT1000 that can measure that timing error, by the way.
and in the MT1040, you have CPRI and things for those networks, right? So
Yes, so yeah, the mobile backhaul, CPRI and eCPRI, and I also see CPRI kind of given away to the eCPRI radio
right.
over Ethernet technology. So
Well, actually, John, I don't see any questions coming up, and this was great. I especially like seeing the screens through your VNC viewer, and reminding me that yeah, the you guys that do the support on the products have some modern tools these days to do that. So uh, I think we're probably towards the end of our sessions. No questions are coming up, so just wanted to thank everybody uh, for coming to the webinar, and we'll have the recording and all of the information for everybody on the slides. Any last words there, John?
Just thanks for putting up with me, and it was uh, it was
Uh,
fun, and I was glad to spend some time with you this afternoon.
yeah, it was very good, very good. Thank you for all that great detailed information. We appreciate it. And I think that's going to be it. So we're going to end the webinar. Thanks everyone for coming, and thank you, John.
All right,
Appreciate it.
thank you. All
All
right,
right.
thanks. Bye.
Bye-bye.